All right. So in this experiment, we are looking to capture carbon through two mechanisms. So the first is in the wood of growing trees. And the second way is through enhanced weathering of minerals, and that will export ions to the ocean where carbonate is sequestered for geological timescales. And so critical to both of these forms of carbon sequestration is the soil pore water, which is basically a technical term for what plants drink. So in the soil, there is water traveling through the zone of the roots, and this instrument called a lysimeter essentially simulates a plant root. So this ceramic tip here has pores in it similar to the ones in a growing plant root, and water can enter this tube along with all of the chemicals and ions that we're interested in measuring. And so this tube will eventually be installed in the ground to our desired depth. In this case, that's going to be about as deep as the rooting zone of the plants. And if you look at the installed one here, what we've done is we have connected it to this vacuum here. And so the vacuum will pull the water out of the soil, similar to the way that water moves up a straw, and then it will be discharged into this sample bottle, and we can take it back to the lab. And so some of the things that we're interested in measuring are dissolved organic carbon. That's food for the microbes that build soil organic matter. We'll be looking at different nutrient ions that plants use to grow, things like phosphate, nitrate, ammonium. And we'll be looking for calcium and bicarbonate, which is what's exported to the ocean from the mineral weathering that occurs here, and we hope generates calcium carbonate that is sequestered for thousands and thousands of years. So some of the plots here have the basalt applied and some don't, and that's because it's critical for us to tell what the effect of applying basalt is, so we need a comparison or reference point. So what we expect to see in the soil pore water in plots with basalt applied is, first of all, more calcium and more bicarbonate, two products of weathering that will be exported. But if the basalt also serves as a form of fertilizer for the plants, we might see higher concentrations of other plant nutrients as well, things like silica that aren't often supplied with fertilizer. And if the plants themselves grow bigger and are more robust, then we might see increased cycling rates of carbon and nitrogen too. So there are lots of aspects of soil pore water chemistry that are likely to be affected by the presence of basalt in these plots. So we'll have technicians coming out about every 2 to 4 weeks, more often during the growing season, to extract water from these lysimeters, and we'll examine the pore water in several instruments in the lab, one to measure carbon and nitrogen, different instruments for calcium and other nutrient cations, and we have ways in the lab of also determining nitrate and ammonium as well.